All right, Algebra 2, I'd like to go ahead and take a look at how things went with us during the practice set and quizzes for 2.4, which was titled More Linear Equations. We've already kind of taken a look at slope-intercept form, which you're very familiar with from Algebra 1, and we definitely found that we need a little bit more support in terms of working with and translating into point-slope form and standard form. So let's begin with slope-intercept, and we take a look at this was question 6. And this was one of the areas, questions where we struggled mightily. Write the equation for the line in slope-intercept form. So we're taking a look at this graph, this line, and we need to kind of zoom in a little bit. And let's see if we can take a look at not only where this crosses the y-axis, but if we can determine its slope as well. If we know the slope, and we know the y-intercept, then we can write an equation in slope-intercept form. So as we zoom in a little bit, we can take a look and we see that here, that the red line crosses the y-axis at y equals positive 3. So I know that my y-intercept is 3. Now we need to identify 2 points where this line passes through. And we want to try to find places where it crosses exactly on the grid marks. And so it looks like we have one here and one here. So if we go up 1, 2, 3, 4 units and 1 to the right, that's a slope of positive 4. Okay, 4 over 1, or 4. So y equals 4x plus 3 is going to be our slope-intercept form of our equation. And that was answer number 2. All right, similarly, let's take a look at number 7. And we're asked, which of these lines has a slope of negative 3? So we know that our change in y over our change in x is going to equal 3 over 1, and it's going to be negative. So if it's a negative slope, this is decreasing from left to right. So that rules out A, and it rules out C. So now we're just looking at B and D. And so change in y over change in x means it goes down 3 units for every 1 unit that it moves to the right. And so as I'm looking at this, that clearly is going to be answer B. What about D? Well, that goes down 1 unit and 3 to the right. So that's a slope of negative 1/3. So the difference between B and D in terms of having success with getting that type of question correct really falls on recognizing what slope means, the change in y over the change in x. All right, let's jump ahead to number 9. So we're asked to give the y-intercept of this equation, 3x plus 8y equals 24. All right, so the x-intercept is where this graph crosses the x-axis, okay? So every point that's on the x-axis has a y-coordinate of 0, okay? It's going to be x comma 0. So another way to think about that is if we substitute 0 in place of the y and solve this for x, it will tell us what the x-intercept is. And you might have had a teacher that said you could use your pencil or your finger to kind of cover up the y term. And that makes sense because when you substitute 0 in for y, anything times 0 is 0, this term is going to go away. So 3x equals 24. Okay, let's go ahead and solve that. Divide by 3 on both sides. So x equals 8. So depending on how the question is asked, x equals 8 might suffice for the answer, or they might ask you to give the actual ordered pair, the point, that represents that intercept, which would be 8 comma 0. So in this case, that was the first answer that was given to us, answer A. So that was working a little bit with standard form. You can be asked to find x and y intercepts. So here's one that was definitely one of the tougher questions in the practice set. We're given a slope-intercept form of an equation, y equals 2/3 x plus 5. And we're asked to write it in standard form. So this is y equals mx plus b. And we want to write it in ax plus by equals c. So we've gone from this to this many times. We've solved for y. Here it's asking us to kind of unpeel slope-intercept form and put it back like this. All right. So let's take a look at what this form is. My x and my y are on the same side of the equal sign, and then my constant is by itself. So if I take a look at this, if I subtract 2/3 x from both sides, I'll be left with just my constant on the right, which is good. That's what I want. Negative 2/3 x plus y. And you might feel a little bit like, oh, we're done here. We're good. Two things. In ax plus by equals c, all my coefficients are integers. So I can't leave this as a fraction. Well, how would I do that? Well, if I multiply by 3 here, I can see that that's going to undo this fraction. So I can't just multiply one term by 3. I have to multiply this by 3 and this by 3. So let's make that happen. So 3 times negative 2 is negative 6, divided by 3 is negative 2x. 3 times y is 3y. And then 3 times 5 is 15. You feel like now we're done. My lead coefficient has to be positive. So I have to multiply this entire thing by negative 1. So this is going to be my standard form equation for this slope-intercept form. 2x minus 3y equals negative 15. And that was this solution right here. It's way more common that you'll get asked to go from the standard form to the slope-intercept form, right, than vice versa. But we definitely want to be able to do that and recognize that they're both legit ways of expressing the same function. All right, and then the last one we had, this one, number 13. And this was just kind of recognizing which of these represents point-slope form of a linear equation. Well, now it's just a matter of, we've been taught this. Can we recall it? So most of us know y equals mx plus b. That's one of the things that almost everybody remembers from Algebra 1, and that's slope-intercept form. And 7 of our classmates in this particular class gave that as an answer. So not only is that the only thing we remember, it's like the only form that we care about. Right? Ax plus by equals c, we just talked about that. That's our standard form. This one is point-slope form. Y minus y1 equals m times x minus x1. Right? So my x1 and my y1, those are the coordinates of the point, and m is the slope. I substitute that into this form. So many times we're asked to translate from point-slope to slope-intercept, but if we're given 2 points or a point and a slope, we need to start here. So I'm hopeful that clears up some of the questions that you had on moving between the different forms of linear equations and some of the things that we can do with them.